software development for non-technical founders. So, this is going to be really dry if you have a development background. A lot of it is kind of repetitious. So because you guys kind of have both different backgrounds, and I don't know what your levels of knowledge are, feel free to stop me throughout if there's something that doesn't make sense, because it can go both ways. I could be like really droning on about, stuff that you already know, or I could be missing something, and, I don't want you to like not know that concept, right? So, so this is what we're going to go over. I have like 5 or 6 different sessions here, or sections. It's general concepts and development process. Then we're going to go through the actual steps of the process: requirements, design, development, testing, and then summarize with some best practices, some of which is repetition from the other sections. So in terms of general concepts, so these are some common terms. So for software development, regardless of what the platform is or what type of development, you've heard things like module. So that's like a chunk of code or a bunch of different features. Function, procedure, method, those are kind of used in small action. It does something, it passes something back out, right? So it could be do a bunch of actions, or it could be take in some data and transform it and send it back out, okay? And then parameters, that's what you pass in and out of these functions or procedures. So you might say, I want to add 2 numbers. So if I made a calculator function and I wanted to add A plus B, A and B are the parameters. They have a data type associated with them, and then they return, a return value. So that's how the constructs of most code work. And then you can have logical expressions and all kinds of stuff inside those functions or procedures. Source code, sometimes this gets shortened to either code or source. Someone says, hey, I've got my source over here, or I've got my code over there. It's the full term is source code. And repository, have you guys heard of a repository before?
No.
So it's basically a storage of your code. So we'll get into like version control and configuration management later on, but it's basically a secure place that you could put all of your source files, and then you can manage their changes over time. So you never accidentally delete something, or you could always backtrack and get stuff out of the repository. A bug or a defect, right? Something that doesn't work right. Some other like roles you'd have in software, like an architect, somebody who designs the system and figures out how everything plugs together. You have a developer. Typically, sometimes they can be the same person, but there's like 3 or 4 different roles. Like you'd have like the manager or the lead that manages a project. You can have an architect, which designs it, and then you can have a developer that implements it, but those could all be one and the same, possibly. And SaaS, software as a service. We're talking about building applications. So the application layer, when you're running a program and you're doing meaningful things and interacting with the user, versus being like the low level hardware type software. UI UX, so user interface, user experience. So there's people you'll find with titles of UI UX, and they lean more towards the graphic design, and figuring out how a user want to interact with it. So, as your companies get bigger, you'll have actually specialists that are doing UI UX. Database, which is like storage of data. Have you heard of like client server type relationships? We'll get to that later, but in your world, when you have an app, there's a certain amount of code that runs on the server that's interacting with the app, and the app is the client. So same as like right now, when you're using a web browser, there is a web server that is sending you information, and the client is your PC or your laptop with the web browser. So that's the client side. So there's a lot of times when you're talking about design and where the code is executed or where the program is executed, sometimes it can be on one side or the other, or on both. So I'll explain that when we get into the languages, but a lot of times—
oh my God, this is so crazy.
So you can slow me down and ask more questions if that doesn't make sense, but
No, it's making total sense. I just wouldn't, if someone talked to me like this, I just would never, I would have no idea what they're talking about. I'm so glad you're explaining this.
That's why we have this, right? And so, especially when you're doing web applications and stuff, there is some stuff that gets processed. So a good example is if I'm browsing LinkedIn, what it's doing is when I do an action on the client side, it's requesting data from the server. The server is going to a database, pulling out information, processing that, and then sending it back to the client. And then when it comes to the client, there might be some other processing that happens there. So you have to think, like, when it comes to design and how your applications work, understanding what is on the client side and what is on the server side. Of course, all of LinkedIn's data is not on my phone, right? There's a database on a web server somewhere in the cloud that stores all the user's data, and it retrieves what it needs to and then serves it up. That's why it's called the server. It serves it up to the client. The client takes it, interprets it, and displays it.
Wow.
QoS, this is more of like in real-time systems, but it's quality of service. So sometimes when you need real-time data, you want to know how long it's going to take to get to the client or the device out in the field. Protocol, this is the language that computers talk. So there's lots of different protocols, but the way in which they exchange data, that's the protocol. Packet, so data isn't just a continuous stream because we work in a networked world with TCP/IP. It breaks it apart into manageable chunks. Those are called packets. TCP/IP, so IP is internet protocol. That's everything is TCP/IP. There's TCP packets running on an IP protocol. Okay, so internet protocol is how. Now you got me. Let's see. TCP. I do know this, but there you go. Transmission Control Protocol. Okay. So lots of these things, like it's funny, as like a software developer, you just use them, and it's like the acronym, but you don't actually, you've never heard that, right? Another one that you run into a lot is API. Have you guys heard of it? A software API?
I've heard of the term.
So it's application programming interface. So it's the way in which two programs talk to each other in a standardized way. So there's lots of applications, like, I don't know, either of your apps, there could be another service that you want to work with that wants your data, or you want to bring data into your service. You'd have to talk to their API, or they have to talk to your API to exchange data.
Yeah, Google Maps is the classic example.
Yeah,
it'll show the map on your screen and it puts the restaurants in there. All that's happening through the Google Maps API.
Then you've got queue. So a queue is basically just a holding place. It's like if you have a whole bunch of messages, you don't have to deal with them in real time. They get put into a queue and then they get taken out of the queue. Then there's a bunch of, so are any of those terms, did you want any more clarification on any of those ones that we went through?
Maybe the quality of service is probably the only one that stands out to me.
So quality of service is really just a concept that's built into some protocols to make sure that it gets delivered on time. So, and a lot of times it's like get delivered in a certain amount of time. And this is really important for like real-time systems where you have data coming from a field device, or, if you've got like a voice call, you'd want to make sure you have quality of service, because if the packets get delivered out of order or the too laggy, then it breaks up the video or the audio. Okay. So it's anything that needs to be done in real time.
Cool.
Okay.
So now we get into embedded, and I know this doesn't apply to you guys, but I thought I'd give you these concepts just in case you ever come across them. So firmware, this refers to software running on a hardware device. So it's not hard software, it's firmware. And in that firmware, you usually have a bootloader. So a bootloader is a very, very small, simple program that allows you to load in new firmware. So if you want to erase, say you have your iPhone and you're going to upgrade your iPhone, what it does is it erases all of the firmware off the device, and then that little program loads the new firmware in place. On hardware, the way that a lot of things are stored is NVM or flash, so non-volatile memory or flash memory. So instead of like a computer that has a hard drive, right, you have flash memory. Kernel, if you've ever heard of the Linux kernel, this is kind of like the main chunk of operation that's in the operating system. Then I'm not sure if you know that your computer has a BIOS or a hardware abstraction layer. So a BIOS is basic input output system. See, I looked that one up because I know a BIOS, but no, it's one of those things that I didn't even know. But a BIOS is something like you install Windows on your hard drive, but before you can do that, it has to have a BIOS, and you can always stop your computer and change some of the hardware settings. IRQ is an interrupt request. So an interrupt, I probably should have put that on here. So a lot of computer programs run like in a loop. What can happen is if something spontaneous happens, it interrupts the program. So for example, I hit a key on my keyboard, that actually sends an interrupt to the operating system to say, oh, someone did this. And then you handle that interrupt. A pointer, this is something it's a way to point to a section in memory. So you don't always just have to have like static addresses for things. You can actually have something that says, where do I find a particular piece of data? Where do I find a particular procedure? As a computer or the IO on your phone, that's inputs, outputs. RAM versus ROM. So random access memory. This is like every computer has RAM. Your phone has RAM. And what that is it's volatile memory. Like that memory can disappear. If you don't keep powering it, the contents of that memory will disappear, but it's really quick to access it. So if you think about your computer, it takes longer to get something off your hard drive, which is persistent memory, like it sticks around. Like when you shut your computer off, your hard drive stays there, right? But it's longer to fetch that data. So when you're talking about embedded systems, you want to have enough RAM that you have kind of the things you need to access over and over again really quickly sit in RAM. And then read-only memory is, it's persistent memory, but you can only read it. You can't actually write to it. And then another thing, and this is kind of more in the realm of like TCP/IP, but more like a hardware level, is a MAC address. So every networking adapter, so like you plug in your computer to the internet, you're plugging the Ethernet cable into an adapter, and that adapter or that card has a MAC address. Okay, so it's a unique address on every piece of hardware that has a networking adapter. All right.
Hi,
So
Naz.
Hello. Sorry, I was just tuning in.
No worries. So that's kind of general terminology, and some of that'll make sense and some of it won't. And if you have other questions about it, some of it will come up throughout. That's why I thought we'd go through it first. So where do you find software? So right now you guys work in like the cloud space and mobile and things running on desktop. These are like really high processing power. You don't have a lot of constraints. So a lot of your software development, you don't have to worry about the hardware. You don't have to worry about resources. And that's cool. But there is a lot of software in a lot of other places where all of a sudden you get into more constrained environments. So these ones are relatively unconstrained. Obviously, the cloud is like fully unconstrained. But whether it's peripherals like a printer or a webcam or a watch, they also have firmware in them, right? So they'll have firmware in those devices. In transport, like in your car, in your plane, like the controls and the sensors and all those things have software in them. All the way down to like whether it's a game console or whether it's a radio or even like your calculator or your thermostat, those all have some kind of software in them. So I always like explain to my kids, right? It's like, I could write the software that goes in your microwave, right? Like something has to interpret the button presses on your microwave and say, I'm going to display the number 1 on the LCD screen. And when you push go or start, something has to be able to start the turntable and start the microwave. So understanding hardware, I don't want to spend a lot of time on hardware, and I'm going to move off of that right after this screen, but the differences between the types of programming environments. So embedded devices, you have very limited resources. So usually it's like power constrained, You don't have a full operating system like you would on your PC. It's a real-time operating system because it has to do things quickly without a lot of delay, right? So there's typically a lot of times there isn't networking. Instead of running a microprocessor, it's a microcontroller. And, we don't have to get into what a microcontroller is too much, but it's basically all the system on one chip. So it's the processor and the memory and the inputs and outputs all on one chip. Whereas once you get into a computer, these have a microprocessor. And a lot of times, while it's still fixed resources, like you have a gigahertz processor on your phone or your laptop, you've got more computing power, but you also take more power. So we're not living in this like, I have to have minimum power world, but there is this trade-off. So if you're going to have things like a full operating system and a multi-core processor, like a quad-core processor, it takes a lot more power. So that's why you see a big difference between, what's running on a smartphone versus what a PC is versus what a server is. They all have different amounts of computing power to do bigger and faster things. And then when you get to the cloud is a collection of computers. So, the cloud is, I want to use more processing power. What it actually does is it's got an operating system that can scale across multiple computers to let you use the memory and the processing power on multiple servers at once. So the cloud isn't really anything special. All it is a collection of somebody else's servers, and it allows you to dynamically access those resources. So it's really easy to say, oh, well, I've got 10 times as many users today, so I'm going to use more processors and more memory, and you don't have to like go and physically install more servers. It just scales across those servers. Does that make sense?
Yeah.
Okay, so essentially in the cloud, you get like infinite computing power and infinite memory as long as you're willing to pay for it. And so you can see from one end to the other, it's down on this side, you're working with limited resources, power, and price or cost. And it gets more expensive and more powerful and more power hungry as you go from left to right. All right, so one more kind of basic concept, data types. So in a lot of times, you probably are going, oh, well, someone just puts this value or selects something on my app or on the website. If there's a number or if there's a piece of text or whatever, it's all stored on the computer in its memory. And so there's different types of data. And so this is good to know when talking to developers. So the most basic one is void, which means nothing. So if you have a procedure that returns void, it doesn't have a return value. So it means zero, nothing.
That's
Boolean is
null, right?
What's that?
Null is the same as void.
Yeah, null would be the same as void. And then Boolean is like true and false. So this is a single bit. It means 1 or 0, true or false, yes or no, right? Like that's a Boolean value. And it's a discrete, like a light switch is on and off. That's a Boolean value. An integer. So this is a number, right? So my age is an integer, okay? And it can be signed or unsigned. So a uint is unsigned integer, means that there is no negative numbers. It can go from 0 to whatever number. So that's what uint versus int means. And then this 8, 16, 32 is how many bits of data. So an 8-bit or a byte is 8 bits of information. So it can only represent 0 to the 2 to the power of 8. So there's 8 distinct states. And then 16 bits or 32 bits. I mean, modern computers now have gone all the way up to 64 bits. Then floating point. So floating point is more for representing a decimal number. So if you wanted to have like a temperature and it's 25.6, you would use floating point instead of using an integer, because you would only be able to do 24 or 25 or 26. You wouldn't be able to do 24.7. A string. This is a bunch of characters together. So remember I said that a uint 8 is a character. So that's actually like a keystroke on your keyboard. You can represent that in 8 bits. And so like the letter A is in a byte or an 8-bit number. And then you string those together to make a word or to make a sentence. So that's what a lot of times you use strings. Arrays, this is a collection of stuff. So if I had like a list of the temperature, every day for the last 7 days, I would have an array of 7 numbers that each held one floating point number. Once again, we already talked about pointer. So this is like pointing to one of these addresses that stores this information. A structure, you can start to get more complex. So you can say, oh, I want to, record a collection of information about this person. So this person, I want to know their age, their height, their weight. So if I'm always going to use age and height and weight, I can actually group that together as a structure called person. And then I can store that for multiple people. So I could have an array of structures that represent a group of people. An enum or enumeration, this is a numbered index kind of thing. So if I had like 3 choices on my website or 3 choices in my app, A, B, or C, A would be represented by 1 and B would be represented by 2 and C would be represented by 3. It's an enumerated list of options. So it can't hold any value. It's just like these 3 defined values. A union, it's kind of like a structure, but all the members of the union are all overlapping in the same space of memory. So this is more of an embedded concept. And then class, and you probably deal more with classes. When they talk about classes or objects, it is like a structure in that you store information for an object. So you would create an object called car, and a car has some properties, right? It's got like fuel level, and it's got speed, and it's got weight, and it's got number of wheels, right? So you can put in information about a car, and then there's lots of things you can do with that car. And so all those properties of car and all the operations you can do on car go into this thing called a class. So it's a more complex data type. And this is how a lot of object-oriented languages represent data. So in a lot of the languages that you guys are going to be using, they're very high-level languages, and they'll have classes or objects inside them to represent it. So, in CrossPath's example, you might have a restaurant, and a restaurant has a bunch of properties, and you can do things with a restaurant. You can book a table, or you can, view the menu, or right. So those all become methods or procedures that you can do on that instance of that class. So a class is like the definition of so restaurant is a class. And then what you do is you use that like a template to say, oh, well, this restaurant here, Moxie's, I can take that template and I can create an instance of that class called Moxie's. Does that make sense, Megan?
Yep.
So the class is really the template, and then the copies of it are called instances. All right, so let's talk about software layers. So it's kind of the end of like the general concepts. So on almost any computing system, you have the BIOS or the hardware abstraction layer, the HAL, that interacts with the hardware to make it so that all hardware really looks the same. So that when you put, these drivers, whether you're on this computer or that computer, they work the same way. So the drivers actually interact with the hardware. This one kind of abstracts the hardware. And then on top of that, you have an operating system. So operating systems do things like sending messages, running programs, providing access to things like, timers and memory. And so it kind of is the coordinator of the resources and shares them amongst all of the apps that run on the operating system. So when you're building an app on a smartphone, right, you think about this. So CrossPath, your app runs on top of iOS, and then iOS actually runs on 5 or 6 different types of devices, whether it's an iPad or an iPhone or an iPod. So the drivers and the BIOS have to be different for each of those hardware platforms, but they try and write the operating system such that it doesn't matter if it's on an iPad or an iPod or an iPhone. So the why this is done, instead of being one big kind of blob of code, is that allows you to replace pieces. So I can replace the operating system without affecting the applications, or I can put multiple applications on one operating system, right? I can abstract it from the hardware. So you'll hear a lot about abstraction, right? So the more you can abstract it, the less that, most of the programming you're doing is up here. You don't even have to worry about the hardware in most cases, unless you want to like send a message outside of that piece of hardware, or you want to access something like a display. But even in then, the operating system typically provides you easy to use methods to access the display. You don't have to worry about when to turn on which pixel. You just have to say, I want to put this image on the screen.
Got it.
All right, so let's talk about the software development process. So we're going to talk about what kind of the major pieces of the software development process there are, and then we'll talk a little bit about what's important and what's not. You always want to have defined roles and responsibilities. So one of the things that I heard from a lot of the companies in Junction was, oh, I have a developer that's doing this. Well, who's the developer? Who's the architect? Who's the development manager or the project manager? And who's the product manager, right? Like there's all these different roles, and it's really, really dangerous to take a really junior developer and expect them to be a development manager or an architect. Those are typically more senior roles. So if you hire a developer and you say, this is what I want to achieve, they're just going to build it however they know. And you're not going to make the right decisions on the architecture. You're never going to deliver on time or do the right processes, because really there should be somebody that's responsible for the process, which is the development manager. And there should be somebody responsible for the architecture to make sure you're building the right thing on the right platform, right? Someone's got to decide what language are you using? How do the different pieces of the software tie together? How do they interact? What are we going to do and when? How are we, what language are we going to use? How are we going to code it? These are really high level responsibilities. And especially if you're a non-technical founder, you really want to make sure that you have somebody that has experience to help you make these decisions, or you end up making the wrong decisions and then you just have to redo it later. So one of the first steps is, requirements and all of this stuff. So you want to have a process of how you build those requirements and how you communicate them to the team. And this is when I talk about process, a lot of times it's getting both parties, so the development team and the product manager, to agree on how they're going to exchange information. And a lot of times people just do it. They just go, make it work like this. But if it's not written down and it's not in a standardized format, there's always misinterpretations, which means you end up building the wrong thing again. Then it comes down to building and releasing process. So you really want to know what are the steps that is going to go through to go from requirements to building it to delivering an output, and how are they going to do it in a logical, controlled manner, so you're not kind of just getting stuff showing up here and showing up there and things are at the wrong time and they're done wrong. You want to make sure that there's a regimented professional process, regardless of what that process is. You want to make sure it's documented and everybody on the team follows the same process. So at any point in time, like if your developer leaves or gets hit by a bus, you want to know where to find things and how things work, so that the next person that comes in can pick this up. So it's more than just kind of knowing where your code is stored. It's also knowing how it's put together and how it creates an output. And one of my really important tips here, this is something that I do. Hopefully your development team is doing this or something similar, is the version number of your software isn't just a bunch of random numbers. It actually means something. So what I like to use is the first number is the major version of features. So every time you have a major feature upgrade, you rev this number. So if you have 2.1.7, right? It's like the first one means the major feature revision, then any kind of minor feature revision, and then bug fix. So if you release a piece of software and there's a bunch of problems in it, but you never put any new features in, you should only see this final number go up. So then somebody can intelligently know, oh, I've got version 2.1.2. Oh, what is 2.1.3? It must just be some fixes. There's no new features. And then a build number, a lot of times, and we'll talk about it in the automation section, is the build. What happens is you build automatic scripts that compile the code or release the code every night. So even when someone's changing it, every night it gets built. Well, then you know what day it was built on, and you can be able to tell the difference between this build and that build. It might have the exact same code, but it was built at a different time, right? And so if someone's putting in changes and not changing the version number, at least you know the build number is going up, and then you can say, oh, well, what build number are you using? That's a traceability back to the source code and the build process to know when it was built. We want obviously a process around how we're going to develop our tests and how we're going to run them. So if there is no test development and execution process, it means it's probably being tested ad hoc, which means you're probably not getting the test coverage you need. You want to systematically make sure that all of your code gets tested, because if it doesn't, if there's no plan, there's going to be big holes or big chunks of your program that are never tested. And then you really want to make sure that you have a way to track defects, so bugs in your code, and you want to involve your beta testers and your users in this. You want a systematic way of people to report defects, to make sure that they're traceable, and then to know what version of software the fix ends up in. So that leads to like release notes. So if you look on my website, you'll see that, you know, version 2.1.7 came out and it fixed these collection of bugs, and there's a bug tracking number associated with it because we recorded it when it happened and all the things that led to that bug. We kept track of it and used it to like assign the work to a developer to fix this bug number 75. And then we know that bug number 75 appears in this version. So when someone comes to you and says, oh, I have this bug, but they're running an old version, you can go and say, oh, well, this new version fixes that problem. So you just have to upgrade your software. So your customer support and traceability becomes really easy, because then you know that maybe they're just reporting a bug on an old version that you've already fixed, and you don't have to go through the hassle of trying to fix it again. And then you want some kind of development standards. So every developer does things differently, but you want all of your code to be developed in the same manner, because you don't want things done 5 different ways so that it's hard to understand. You want some consistency in the way in which the code is written. So that means that you should have some coding standards that say how you should name things and how you should arrange things. You want a branching and merging strategy, and I'll get into what that really means. But you know, you can have one main piece of code and you want to try to do a separate feature. You can actually take a copy of it. That's called a branch. You can experiment on that copy, and then when you're happy with it, you can take those changes and put them back into your main line of code. So that's called branching and merging. And then you want a standardized way of logging and handling errors. Bugs are going to happen. Things are going to happen. If your app crashes or it can't do something, you want to make sure that that's reported and recorded in a proper manner. And what it really means is if you're going to report an error to your user, that's got to be traceable back to the code, so you know what area of the code that problem happened in. So having a strategy around how you log errors and how you log the operation of your software is really important. So there's probably lots of other processes. These are the main ones I think are really important. Like your development team should be able to have an answer for all of these. If you ask them, what's your test development and execution strategy? They should be able to answer that question, right? Well, what are your coding standards? Oh, we don't have any standards. You know, at the beginning, you're not going to have any of this stuff. But as soon as you have a program or an application that's released out to your customer base, the risk of crashing that and making them lose their data and everything becomes exponentially higher. As you build out a development team, you need to have a systematic way of doing this, because remember, more cooks in the kitchen means more problems. So if you've got a development team of 10, right? Well, if it's not properly documented and the process is different, like if you have one developer, he's going to do the same thing over and over again. But as soon as you've got 3, 4, 5, 10 developers, it's going to be a mess. And you're going to have all kinds of problems that your customers are going to see. All right. So who knows anything about software development methodologies?
Probably Liam.
Scrum. All I know is Scrum.
Okay, so Scrum is part of an agile process. So these are the 2 different processes. I'm going to tell you when to use what. You guys are probably used to using an agile process right now, but the more traditional one is called waterfall. So what it's called waterfall because you fall from one step to the next to the next. It has a delineated start and end. You gather requirements, you know, you do a design, you implement all these features, you test it, you release it. Ta-da, you're done. You got it all right and you're good. Okay? And I'll explain the situations, but that's really a common thing in embedded firmware, or when you're going to release a program that you're going to release like Microsoft Word, right? Like something that is released once and then really infrequently changes. You figure out what you're going to build, you build it, you test it, you release it. And then later on, you might come back and fix a few things, but your kind of start and end is defined. Agile, on the other hand, you'll notice almost the exact same steps. It's just organized differently. So when you're starting your first version of your app, you need more requirements and more design. So almost your first version of your app development looks like waterfall. But what you do is instead of going into maintenance, you loop back. So you see, we go requirements, design, test, deploy. And what you've deployed, now you go, what are the new requirements? What's the feature I need to add? And so you do these things called sprints. So it's like doing a whole bunch of little waterfalls more rapidly. And you do this because you want to get a product out there. And then your customers say, well, I want a new feature. I want it to look like this. I want you to add that. And so an agile process makes it so you can rapidly change it. And there really is no start and end. There's definitely a start, but it goes on forever, right? So you see like a lot of web softwares like this because I'm using LinkedIn and LinkedIn's been around for 10 years. It keeps evolving and they keep releasing new features and they keep changing the interface. It's never done, right? So if we look at like how you decide, so waterfall is like you want to spend more time up front to get it done right. You have this defined start and end, use it where there's iteration is not desired. If I'm building a thermostat that's going to go on my wall, right? You don't want to really have to upgrade that again. You want to get it right one time and send that out and you never touch it again. Like a sensor on a car, you never want to like rip apart your car to update that sensor. So you really got to get it right. So you put in all this effort up front to get it right. Agile, on the other hand, you want to get it moving quickly. I mean, you still want to put a substantial amount of time at the beginning before you write the first line of code. Because if you don't know what you're building, it's just going to be haphazard. But you do like a miniature waterfall. You get it moving, and then you've got this ongoing development, and you're just doing this loop again and again and again, and you break it down into sprints, which are manageable chunks. So you're always getting, no one's ever waiting forever for a feature. Waterfall can be like, we do some waterfall design projects that take like 2 years. And so the customer never even gets it for 2 years. And so you don't want to find out you did something wrong on day one. So you have to spend a lot of time to make sure that what you're going to output is going to be right. All right. And the key thing, just one last thing, is the key thing with an agile process, it's got to be really easy to deploy this. So like in a web environment, if you make a bunch of changes, it's pretty easy to update the website because everybody's using one copy. It gets a little bit harder when you're talking about an app because think about it. If you're releasing a new version of your app every 2 weeks, then your user has to download that app every 2 weeks, right? So, things where there's a remote component, you want a little bit shorter or a little bit longer cycles because, maybe it's okay to update your app every month, but no one's going to want to update their app every day. And that's one thing for you to consider, Megan, is when you're talking about a web version of something versus an app version of something, one of the benefits of having it on the web is that centralized copy is updated more frequently. And so when they go to use your service, they get the latest copy. They don't have to worry about downloading the app again and again and again. So yeah. That's just one thing to keep in mind. All right. Requirements. So now we're getting into more the
app doesn't just self-update.
Well, it can if it's turned on.
Yeah, I think it's. What's that? My camera?
No, I said that if the app update is turned on, I mean, it's become more automatic, but sometimes people don't have that turned on, and so they've got to go out and do it. And so, yes, you could get quicker at doing things as long as their contact stays on the phone and they don't have to start over again. So there's important things that come with updating software, and it's persistence of their settings and, making sure that people have that app update turned on automatically, right?
Yeah.
All right. So let's get into the development process. So that's all the background. So how much did I take? Oh, we're at 2:47. So I got to pick up the pace. Gathering requirements. So, I mean, you guys went through this. You guys went through like trying to get requirements, probably went through like building user stories. That's more of a product management thing. Developers are not typically business people. Just as much as you guys aren't really technical people, it's hard to expect technical people to talk to customers. There's a lot of really good technical people that can never be put in front of a customer, and they just don't think the same. And they think about how it should work, not how the customer wants it to work. So it's really important to separate your development team by default from product management. maybe you can record some stuff, or maybe you can bring them along once in a while, but a product management person should typically have a marketing or sales type focus because they understand the customer and the user experience that they want. And then it's really important. Don't just go, oh yeah, I want an app that gives me a list of restaurants. You want to know really, really specifically what the customer wants. Like, when I click this button, I expect it to do this, right? Or when I do this, it should take this long for this to happen, right? So, here's some common questions, right? Like, how do they currently do things, right? Because if you want to try and mimic what they're doing already, what does that ideal system look like? What are the inputs and outputs? What should the interface look like? What colors do you like, right? Like, what kind of buttons do you like? Right, as much detail as you can, because if you can give a really
question. Sorry
Yeah.
to interrupt. Wouldn't this fit more towards the UX UI designer role more so than the project management role?
Yeah, it depends on the company, because a lot of companies start out without a UI UX person, and it's the product manager getting requirements and giving it to a more generic development team. But yeah, once if you want to drive the aesthetics and the UI UX from internally, then you have to have a UI UX person. But in a lot of times, customers, at least in the early days, will go, hey, I want it to work like this product over here, right? Like, we were building an app store and we didn't have a UI UX person in our company. We said, hey, developers, make it look like Apple's app store, right? So, but the more specific, the less specialists you have, and specialists come over time. If you don't have a lot of specialists, you've got to be really specific, paint them a picture, right? And then, also help them delineate, what we must have before the customer will adopt this, and what's a nice to have that can come later, because that's going to help you set those relative priorities, right? So really making sure that the minimums are in there before minimum viable product. I'm sure you guys are all past that minimum viable product now. And you really want to make sure you document everything. I have a really, really bad habit of going hand waving, going, make it work like this, right? And then I walk away and the developers forget what I said. So you really want a process of how you capture this information, how you give it to them, how they acknowledge that they understand what you've given them. Like, in any successful communication, you need that acknowledgement, right? So here's what I'm giving you. This is what I want you to do. Okay, this is what I understand that you want me to do. So, we'll talk about closing that loop in a second. So user stories is a really common way of doing things. There's lots of different templates. The basics of it is like, defining the type of user, what task they want it to perform, what the goal or the output is, right? That's what a user story usually has. And then you got to have some validation or acceptance criteria to know that it's working. So like an example of it. And then if you break this apart into user stories, this can become requirements for a feature. And then you expect the developers to tell you where it falls in the priority, how much time it's going to take. And then if you've broken it apart with user stories, you can rearrange these as needed, right? And I'm sure like through Junction, you guys probably talked about user stories.
Mm-hmm. Yeah.
Okay. Because it's more of a product management thing. And then though, so you've got a set of customer requirements or user stories. The technical team should take that and translate that into a system requirements document. Okay. And what that means is they actually go and they translate all these customer-centric information into technical speak to say, we're going to have this much processing power and we're going to have these many applications and we're going to have this feature and that feature. And they translate the customer experience and stories into an actual technical document that says how the system has to work, because the development team, only a certain amount of people can do this translation. You need a design document, a requirements document that really paints a picture for development staff. And a lot of times people will skip this step, but as the development team grows, you want to make sure they're all on the same page, and the system requirements document is important. Then, when they do that and you read that system requirements document, you're going to find out that they missed some things or they misunderstood it, because if they put it in their speak and then you read it and you have them explain it to you, it should sound a lot like what you were asking them to do. And that check and balance makes sure that they don't run forward and build the wrong feature because they misunderstood it from the customer perspective. And the more technical your team is and the less they know about the customer, the more important it is to do this, because if they don't understand the customer, they might not understand your requirements. And so they should come back and ask more specifics. So if you said, hey, put in a wireless connection here, a technical question would be, what's the range of that wireless link, right? Or how long should this last on battery? How long should this take? You know, how should this appear? When should it appear, right? So they are going to want tangible numbers, because a lot of times when you're thinking about customers just expect things to happen instantaneously, but there are some things that might take time, and you want to know how much time is acceptable. So system requirements document really gets more specific, the specifications that are going to be used to drive the design. Because if you pick the wrong language or you pick the wrong technology because you made an assumption about what the customer wanted and it takes slower than it should, you go back to the drawing board later on. So once again, the product manager should read this system requirements document and understand it and make sure there's no gaps. And, you know, I always, in my business, we don't proceed until this is done. We don't do one line of code. We don't do a line of code until the design is done, and we don't do the design until the requirements are done. It just prevents false starts. All right, so the design phase, once again, don't let your developer skip the design stage. It's so easy to go, oh, I kind of want an app like this, and you start coding the app. But, you know, it's tempting to just get into it. But if you don't know what you're building and you just start building it, you're going to rebuild it and rebuild it and rebuild it and rebuild it. And it's going to waste so much time when you could have just spent a little bit more time on the design. So, you know, and once again, as the team grows, you want all of the team members, especially if it's like this developer's doing that module and that other developer's doing this module, you want everybody to know how these modules interact, because if they speak a different language, those two pieces of code aren't going to work together. So you really want to make sure that the development team's on the same page, and it allows you to catch design flaws. Because once you have the design in front of you, even though it's probably mostly pictures with a bit of written words, you go, hey, wait a minute, don't we need to get that piece of data from over here? And well, that's not going to provide me what I want. And so you're able to catch mistakes in the design before it gets coded, and you find out that it's not going to work. And so once again, this is all about avoiding rework and adjustments and having to do the same thing over and over again. So I ask you this, it's like people that say, well, I don't need to do the design, I know what I need. It's like, would you build a house without having a set of blueprints? Right? Oh, hey, I want this contractor to come in and build the construction of the house, and I want this person to do the electrical. Well, if they're not on the same page, things end up in the wrong place, and you end up redoing it as different steps happen, right? So you need the blueprint.
I have a question with design, with regards to the design. So I'm the one that's designing how the app should look like, and you doing usability testing and everything. But is it a fair assumption to have that whatever we design can be coded?
Yes and no. You have to be able to, like, you know, you tell the developer what you want, and if they say they can't do it, is it because they don't have the knowledge, they don't have the skills, or it physically can't be done? And so you really, as the product manager or the CEO, you got to figure out what bucket it falls into. And if you don't have a senior person on staff, it gets more muddled. That's why I always, like, I don't build a development team without having at least one senior person that has the experience to know what can and can't be done, so I can trust that person when they say, we can't do it like that. And then it becomes a negotiation. They go, well, I can't do it like that, but I could do it like this. And then you have to, as the product manager, say that's acceptable or not. Okay. Now, I want to be really clear with you here. What you're doing is not design. While you are maybe designing the user interface, what about all the interactions and the data models and how things work in behind the scenes? Because there's not one way to code things, and there's not one way for the data to flow. You want to design what's in the database. You want to design the different pieces of software and how they're going to interact. And I'll actually show you how you do that, or what they should be doing and showing to you, because you're going to say, I want to click this button and here's what I expect. But there might be a whole bunch of things that happen in the background to get you that result. So this is UML. And Megan, you and I were kind of chatting about this, and I don't know if you looked it up or not, but it's called Unified Modeling Language. And so it is a set of diagrams or set of diagrammatic techniques that help you illustrate the design of the software and the flow of the data. So what they've done is a lot of people were designing things different ways. So what they did is they kind of took all of the common things and they put them together in a unified language, UML. And so there's different, kind of two different categories. You either have structural. So it's like, well, how is the data organized, or how do these objects work together? And then there's behavioral. So that's more, I do this and then this should happen and then that should happen. And it's, state machines and timing and interactions. So this is clickable. I can send you this presentation later. But if you look up UML diagrams or UML modeling language, you'll get a whole bunch of different things that you can use. And you have to pick the right tool. And I picked some of my favorites just to give you an example, and you can look up the rest. But this is a class diagram. Remember we talked about like a customer is a class? So here you go. This is what a class diagram looks like. So even though we're not coding it here, it lets me say to the developers, or the developers put it like this, okay, a customer is going to have an ID and a name and an address and a phone number and account number, and we're going to store it in an integer or a string. See why I wanted to go over the terminology first. And then these are the methods. When you have these braces behind it, this is an action or a procedure, a function. So a customer, these are the data that we store for customer, and these are the actions we can do for a customer. So this is a banking one, I think. So we can do general inquiry, we can deposit money, withdraw money, open account, right? If this is a bank account, they should have a balance. I mean, I guess here is account, and account is related to customer. So this is how a database looks internally. This is a way to model it. So you know what the relationship is, and it says it's 1-to-1. And this has a star. So it's saying I can have one to many. So one customer can have many accounts. So as long as you know how this language or this modeling language works, like this is something that you guys can understand, right? Like a customer, so multiple customers can interact with multiple tellers, and a bank can have multiple tellers, and multiple customers can work with a bank, right? So as soon as you see this, now all of a sudden you understand object-oriented programming and using classes, right?
Hey, Mark, what's the 0 there for the loan?
They don't have to have a loan.
Oh, okay.
Right? You're not going to have a customer at a bank that doesn't have an account, but you could have a customer that has an account but not a loan.
Right.
Okay. And then you can see it's further defined as you could have two different types of accounts. You can have a checking account and you can have a savings account, because a savings account might have interest, right? So this is a really simple example, but this is all of your programs have a database in behind them. You should be able to ask your development team to show me a UML class diagram, to show me that. And what they've probably just done is they created customer and they started adding fields in the database, and they didn't think about it ahead of time. And then later on they went, oh, you know what we also need for customer? We need to know the number of dogs they have, right? So, what happens is they end up changing it on the fly, and then there's never really a written record of what's there because they just did it in the source code instead of designing it first. So you can challenge your design teams. I think you're going to get a lot of answers you don't like, but this is just, maybe you don't have this today, but this is what you should think about moving towards as your company gets bigger and you have multiple developers. This is another one. This is another one of my favorites. This is a sequence diagram. So this is between a user, a device, and a database. So this is a good, like a smartphone example with a web database. The user opens the application. Well, the device accesses the webcam. Then it goes to get a photo. But to get the photo, it's got to detect a face, and then it's going to display the mood, right? And so you can see what has to happen in order. It reads from top to bottom, left to right. So you go, okay, this retrieve mood, well, that retrieve mood doesn't happen until after I detect the face. And I need to figure out the mood before I display the mood, right? So you can see what interactions there are between pieces of software on the client or the server, okay? Oh, once depending on the mood, I want to retrieve some music and generate a playlist, and then I want to play the playlist, right? So once again, a really simple example, but all of the interactions that came from your user stories. So Naz, when you're talking about, oh yeah, I designed this interface and I click this button and I expect this, there's like 50 different things that happen in the background to get you the action you want.
Mm-hmm. Okay.
And then here's another way to like model use cases. So when you talk about, there's this module of code that's called telephone catalog. There's an object called telephone catalog. It's like, well, who's going to want to check the status or place an order? Like who has to interact? And so this shows you when you have a piece or an action or a piece of code, who's actually working with it. Oh, well, Customer can do these 3 things, but the salesperson only needs to do this. So this really helps you set views. So if you have a application that has a front end and a back end, so tutorship is a really good example of this. The tutor sees different things than the customer, because while there's a bunch of code that, there's courses, well, the tutor needs to be able to post the course and the customer needs to be able to retrieve the course, right? So it helps you organize that. And then when a developer gets this, they go, oh, well, I'm building the salesperson view. This is what salesperson view needs. So it helps you group those instead of having like everybody sees everything, right?
So if you had a full team, what would be the job title of the person that's making these UML diagrams?
So it'd be the architect. So the person that's architecting the data models, architecting the software modules, they're the ones that should be saying, we're going to use this language and we're going to design it like this. Because if you just go to like developer without an architect, just a bunch of people running around and bumping into each other, and it's chaos, right?
Mm-hmm.
All right. So there's lots more UML diagrams and we won't go through them all. And what do we want to talk about? One other design concept that's really important. And this is modularization, or in the modern sense, it's called microservices. So this is an example of something like an Uber type thing. What they do is they don't write one big chunk of code that runs. They break it all apart into really tiny pieces. So something like taking payment, something like billing, something like managing the passenger, what the driver sees, what the passenger sees, managing the trip, notifications. It's all broken apart into small, tiny pieces. And the reason we do that is one large program is really difficult to maintain and upgrade, right? So someone might not notice if you take down the notification program for a split second to upgrade it, but you can still book a trip and the passengers and the drivers can still do what they're doing, right? You can take down one of these things and delay processing something to upgrade it. So it becomes really easy to break apart the work, becomes really easy to break apart like the actual testing of it, the deployment of it. And then, of course, now we can see, Megan, there's APIs between all of these because these are different pieces of software, right? This billing has to have an API, and REST or RESTful is just a type of API. So don't worry about that too much. But this trip management needs to access the API from billing, right? To be able to tell it, hey, the trip completed, bill this person.
Yeah.
Okay. Does that microservices make sense?
It actually, to me, is like the most attractive way of coding. I don't know if that makes any sense, but it seems like it would be easier to fix anything or find any bugs if it's all kind of, segregated like that.
Yep. And a lot of times code is broken up into files, but and then you can find things in a file, but a lot of times those are all combined and compiled into one. And then that's one big heavy piece of code that's it's more cumbersome to upgrade. And if you think about this, an example of this is like, you think about your iPhone, you don't have to upgrade your entire iPhone every time there's a new app, right? You can just update the one app, right? Same kind of thing. It's that modularization. It applies to an app. We can actually break that one app into a bunch of modules so that we don't have to upgrade everything.
Would you have to start with that system, or could you then implement the modularizations later, or would you kind of have to just start coding that way?
Yeah, I think you'll probably pivot over time. Like as you added new features, you could make it a different module instead. And this, just so you know, for your example, this might not be as applicable, but the functions that you do on the server side, that's really where a lot of this processing can happen, right? So, a lot of these tools in this example would actually be running on the server, right?
I just think it would be so much easier to have both restaurants and users be able to be segregated like that on the app, rather than have the restaurants on the website and then the users on the app. But I'm just thinking out loud.
Yeah. You just have different views, regardless if it's web or the app. You just have either different apps altogether. Like if a good example is, have you ever used Eventbrite to book a ticket to an event or something?
Yeah.
Yeah. So if you look at that, there's two different websites. One is like what I use to book an event that I want to go to. And then there's a separate application that's built there. And you maybe get through the same menu, but there's a separate application for event planning. And so it's two different views. And then same on the app there's an app for Eventbrite to see where my tickets are and what events I have coming up. And then there's a separate app for event management, because each of those stakeholders don't need to do the same things, right? So you separate it based on the use cases that I had in that UML diagram.
So would you say then it's more like expensive to have 3 different apps, or like
No. You just have to make sure that when you design it, you break it apart and think about it. This is why design is so important, because you probably never had this conversation with your developer about what kind of design methodology or how we're going to design it or how it's broken up. It's probably just like, hey, we want to build this app, right?
Yeah.
And, tutorship, this probably matters to you guys a lot. And hopefully that's what you guys have done, because I think there's probably a lot of different things based on what I've learned about you. There's a lot of different things happening in the background on the server, right?
Yeah.
All right, so let's get into development. I'm not going to get done in time if I don't hurry up. All right, so when it comes to selecting languages, like, did you guys go through a process of picking a language, or did you just tell a developer to build it and they picked one?
They picked it.
We decided based on how we want, like, our future plans. So we wanted to transition to both mobile later, so we decided to go with React.
Okay, perfect. So you would like to kind of at least make a conscious decision here. And I'm going to tell you how these languages are different. I'm going to give you some general things of how you pick a language and what it means. But this is just a popularity of languages based on job postings. So it's not a perfect science. But there's been a lot of movement to Python, and that's because there's a lot of like Linux-based environments, Java, JavaScript, C and C++. It's interesting that they group these two, because C and C++, one is procedural and one is object-based. And I'll talk about that later. But you can kind of see, there's Ruby on here and Go and a whole bunch of different ones. And everyone always invents a new language, and they all have their pluses and minuses, but you got to try to understand the pluses and minuses and what factors are going to drive your decision. So this is how you select the language. Now, these are the things that at least matter. So the platform it'll run on. So there's certain technologies that lend themselves well to the web. So like JavaScript, HTML, some people use Ruby other than, it's more of a mobile one, or you've got like Angular, which is also just another form of JavaScript. On the desktop, right, running on Windows, you're usually going to use like a C++ or C#. And in embedded, you're going to use a lower level language like C and assembler. And I'll talk about what these different levels of languages mean, because each language takes different amount of processing power. And so when you're in a constrained environment, you can't use a very heavy language. It takes a lot of processing power because it will take too long and it will take up too much power. Okay. But as you get up into running on a web server, right, we have infinite resources. You can use these languages that take longer to process, because you got a much more powerful machine. Compiled versus interpreted. Do you guys know what an interpreted language is versus a compiled language?
No, not.
I know what compiled is, but I don't know what interpreted is.
Okay, so compiled, that's what we do on our hardware, is I don't want to just take the text that's in my code. Like, programming is written in with letters on a keyboard, right? So you actually can read it. If this, then that, right? Like, it's very much English readable in a lot of cases. A computer understands ones and zeros. So how do you get text to ones and zeros? Compiling a language means that the machine, the desktop that I'm writing my code on, it interprets all that text, turns it into machine language so that it becomes ones and zeros on that program. So it takes some time for it to compile. Sometimes it can take, depending on how big it is, it could take a minute, it could take 10 minutes, it could take 5 hours. So there's a lot of work up front. And then when you put it on there, if it doesn't work properly, you got to go back and change code, and you got to compile it again and then put it on the device. And so it's a longer cycle, but the code runs way faster because the machine can just digest it. You've already done all the digesting ahead of time. You're just giving the machine the nutrients or the information it needs to work. An interpreter or an interpreted language, you don't compile at all. So when you're doing JavaScript, I write text in a JavaScript file, and then I send it to the web browser, and the web browser in real time reads the text and says, what does that mean? So it interprets what the text means. But you think about that, if I can have the word true or I can have a 1, it's way quicker to process 1 than it is to go, oh, it's TRUE, and that means 1. So you see how you'd have different things. So we'll get into it in a second here. I got a little bit of a graph that'll show you. Another thing is procedural versus object-oriented. So procedural languages, like the ones like assembly and C and some of those, they have functions and they do something. You say, do this, and it does it and returns a result. And then you go do this, and it does it and returns a result. An object-oriented language, it has the data and all the methods inside the object, and then you can create and destroy objects, and they have a life, and they have things that you can operate on. So everything's grouped together. That's what an object-oriented language is. So once again, an object-oriented language is more complex, right? And it dynamically allocates memory and removes memory. Whereas a procedural one, you kind of have to already allocate the memory that it's going to access. So once again, higher level language versus lower level language. And then we talked about client versus server side earlier. So the server, the program runs and then it sends the output to the client. So, a server side application might access a database, look up some data, do some math on it, and then it sends the result to the client. The client just gets the result. It doesn't have to do anything with it. It just, here's the information. If it's client side, what it means is most of the information sent to the client, and then it has to process it and do something with it. So when I talk about a server side language, okay, well, we're going to write C and C++ because we're going to have a lot of chewing done on that server. And then, on the client side, maybe we have a JavaScript interpreter that processes that JavaScript. So you can have client side languages and server side languages. So all of these, this kind of comes up with a matrix of what language you would pick. And so if you kind of know what you want, does it need to run fast or do you want to do fast development? And so what I did is I organized some of these common languages here. So, and I skipped over one thing and I kind of left it for here is, so I said like C++ and C# and Go and C and assembly. Those are compiled machine code languages. You compile them ahead of time. Up here, you have Python and JavaScript and Visual Basic, which is all interpreted. And then you have these hybrids where you partially compile it and then you do a little bit of interpretation. So things like Java and Ruby and PHP, it gets partially compiled. And so what this all means is if you're on this end of the spectrum where it's all interpreted, the development's way quicker. You can modify the code, send it somewhere, run it, right? Like you can see what happens. It's really quick to do development and to like deploy it. But it also, because you just send it there, it has to be interpreted in real time, it takes longer to run it. So something that's interpreted runs way slower. So in my world, a lot of embedded computers, people are writing Python to do really, really quick interpreted development. And then once they figure out what they want it to do, they go back and rewrite it in C so it runs fast. So, it's all about whether you have the resources and you can wait for it to be processed and you want to do really quick development. Like most app and web development is in this sphere, right? You use a lot of Angular or JavaScript, Python, Visual Basic, right? And then of course, the other factor is availability of developers. You might say, oh, well, I'm going to do it in Java because there's a lot of Java developers around. Okay, we good? We good there?
Yep.
Yeah, I don't want to go into explaining every language. I just want you to know kind of the factors to consider when picking one. Okay. All right, version control and configuration management. So version control and configuration management are a lot of times the same tool. Version control means I write a file, store it in my repository, right? And then later on, I go and I want to modify it. Typically, I can't just modify the file because I don't want to like have anybody screw it up. The user has to check it out, modify it, check it back in. So it's like taking something out of a vault. You go to the vault, you pull it out, you can manipulate it, you put it back in the vault, but it's always safe. And version control means you keep a history of that file. So if somebody, junior developer comes in and totally screws up your code, if you have a code sitting on a folder on your computer and somebody changes it, you don't know what it was before. If you have it in a version control system, it keeps version 1 and version 2 and version 3, and you can always go backwards. You can revert to an old version. So you have like this audit trail. You never lose changes, and you know who changed what and when. So when somebody, all of a sudden somebody breaks something, and in your production, you push that button and it doesn't do what it should, and it used to work, you can go backwards, find that bug, and find out who introduced it and how. So, and then configuration management means you can keep, you take a copy, the code, and you can have different copies of the code. And you know, well, this is for this computing platform and that's for that computing platform. And so you can have different configurations of your software. And this becomes important when we talk about doing different environments for testing and production instead of just having one development environment. So you can see here, this is what a branching and merging strategy would look like for a version controller configuration management software. This is a starting point. So I develop and make a bunch of changes, and then at some point I stop and I say, that's version 1.1. And I make some more changes, and I stop, and this logical point becomes version 1.2. And I can label it. So I've got a collection of source files. I say, this collection of source files is version 2, or this is version 3. Now, what I can do is, say that I've got some developers that are working between version 1.1 and 1.2, but I want to do a new feature or I want to release it to a test version. I can take this static version and I make a parallel copy called a branch. And now development can happen on both of these. So what happens is, and this is classic, is I release version 1.1 and I release it here. And the development team keeps doing development features. But during the testing phase of the project, someone finds a bug. What if this development code is moved out to here? You don't want to fix the bug here and release a new version because there's new features introduced. What if those new features created other problems? So what you want to do is on this branch is where you fix the problems with that release 1.1. And then when you're happy with it, all those changes, so you can release that version now to production. But you want to make sure, like if I made it on this branch, I want those to go back into the main line. I can introduce them back in. I can merge them back in.
When it comes to merging, does it not, when like overriding codes and causing more issues when you do?
Well, you hopefully aren't changing the same thing. And most version control systems are smart enough to go, oh, this procedure was modified and this one wasn't. And if there's a conflict, if it goes, oh, 2 people modified the same thing, it'll say, resolve this for me. Which one do you want?
Okay.
So these version control systems are smart enough to know that if people edited different areas of the same file, it will actually take the latest of each one.
Okay, so
and it has.
Sorry, when you have like a team of like 10 developers and they're each doing their own thing, do they all merge them separately?
You can do a couple different things. They could all be working on the same main line. Or what you can do is, and I have it in here, you can have developers have their own branch. So what happens is the main line doesn't really normally get touched. You branch off a version at a certain point, and each developer works on their feature, and then they take turns merging their features in to create the main line again.
Okay.
So that's called a private branch or a tower, that you basically take a copy for that developer and then you take their changes and you merge it back in. So that's why it's really important to have a strategy around how this should work, because if people are randomly taking copies and then randomly putting them back in the main line, it's not controlled. So this is all about controlling the way in which changes are made and introduced back into the software. And what's really important here, and I'll highlight it again later, and I think I've talked to each of you guys about this, is you should have a minimum of 3 branches or 3 environments that you have some people working on development, you have some people working on testing, and you have some people that are maintaining production. So this might be a operations person that's handling production. This might be a QA tester that's on test. But when the developer, when a problem is found on the test branch, it should get fixed on the test branch, and that should get resolved before it ever goes to production, and it should go back into the main line. The worst thing that can happen, and I've seen this happen so many times, is somebody will fix a problem in one branch, and then this branch will never get merged back in. And then later on, you release a new version into test or into production, and it doesn't have that bug fix, and you have the same problem reoccur. And then what you'd like to do is you'd like to automate all of this. So these like the building of all this should be done, like if it's compiled, it should compile nightly or whatever, or there should be like an automatic way that you just push a button and it moves all of the files to test or to production. You want to minimize the disruption this causes, especially when you're touching production, especially on a website, right? When it's live, you want to make sure you have minimum downtime. So there should be some kind of automatic build scripts or deployment scripts. And then there should be a document that says how that works. And you can see like this can get pretty complex, especially as your development team gets bigger. And if it's documented, it's way easier to onboard people, or if you lose your main developer, then the next one comes in and can pick it up, right? Like if you document things like design and release processes and all that stuff, then it's way easier. You're way less susceptible to being screwed by a developer leaving or a set of developers leaving. All right.
Yeah.
All right, so I'm gonna blow through the last one here and try to like leave some time for questions. So testing. So there's a lot of different kinds of testing. And so I know that you guys are probably just like, hey, test this app. But these are the levels of testing that your team should be doing. So unit testing. So I'm building the billing module. I should test that with inputs and outputs and make sure that that module alone works. So that's a unit test. Then I have system level testing. So I put all the units together and make sure they interact and make sure they do the right things. So it checks those interactions. You can get kind of like full end to end. This is probably what most people are doing. Like the unit testing might get skipped sometimes. Regression testing. So if someone goes and puts in a little bug fix or puts in a new feature, you don't just test that feature that was put in. You test every other feature, because what happens in code a lot of times is one thing might affect something else. And if you don't regression test the things that you apparently didn't touch, bugs get introduced and you never know it. And so you really would like to automate this, because this is onerous. If I change one thing that shows up on this screen, having to go back and test every other screen is a pain in the ass. But if you can automate it, then you can do it overnight or whatever. But this is another thing that most companies don't do, and they end up with like really buggy software because they introduce stuff all the time. And the more features you put in, the more bugs you put in.
So my friend recommended this thing called Selenium, and is that what it's for, like automation testing?
Yeah, I'm not sure, but probably if it's an automated test suite, it's probably to do regression testing. Because, you know, it's hard to automate something like a test on something new, right? Like if you build a new feature, how do you know how to test it, right? So you kind of ideally, and this is really hard to come by, but you want your developers to think about how to test something before they build it. Because the worst thing is they build something and then they can't test it. You want to go, tell me how you're going to test this. And then that designs the test case. So when it's done, now you have a test case. And if you can automate it, it becomes part of the automatic regression testing. Okay. But you'll have to kind of build up that suite of tests over time, but you have to have built it and tested it once by hand probably, and then you automate it. And then there's another level of testing called validation. And this is more like user level testing. So, this maybe even the product manager is doing this to go, okay, does it work the way that the user said? It's just confirming. You're not looking for bugs. You're just making sure that it worked the way it was supposed to based on the requirements. So if you think everything kind of matches together, if the product manager writes the requirements and the user stories, then they should be able to test against those user stories at validation, right? And if you properly do the design, then you know how the system should work together. So you can do the system level testing based on the system requirements and the high level design document, right? So kind of incoming and outgoing, it's like a closed loop system where there's checks and balances throughout. All right, deployment. So testing is probably the biggest thing that needs to be done, but I know it's the lowest section. It's just you got to do a lot of it and you got to do it continuously. Deployment, schedule your deployments. Don't let people just put changes into production whenever. Think about strategically, when do you have the least amount of users? You know, when do you have the least amount of system usage, and schedule it. So that might be, you know, in the middle of the night, right? You want to like make sure your users know there's downtime so they don't get pissed off and all of a sudden your stuff doesn't keep working. But you say, hey, between 1 and 2 a.m. on Saturday night, we're going to make this change, right? And you think about your specific user base. When are they not touching? And if you have stats in your software, you'll know when they're not touching your software. And then so you pick the middle of the night or on a weekend based on your usage. And then in general, always assume there will be issues, because there will be. Your developers will consistently break your production system. So make sure that you schedule a wide swath of downtime. Make sure you have resources available. Make sure you have a contingency plan for when they screw up your production system, because they will do it. And so when it comes to contingency planning, these are some things you can do to protect yourself. Make sure you back up your production environment. So you take copies of databases. When you're talking about a live production environment, yeah, you can replace the files from a copy out of your version control repository, but the live databases and all the users' data, if you lose that, you are screwed, right? So you really want to make sure you're backing up databases before you make changes. And then if you've got a backup of it, you can do a quick restore, and maybe something unexpected happened. Well, what you want to do is just recover your production environment and then go figure out why that happened and do it in another environment, create another fake production environment and do that deployment again, and then figure out how to resolve that before you go back to production.
Mm-hmm.
So, plan it out, make sure you have resources. Don't just assume it's. Developers are notorious for thinking everything will work perfectly. And one of the things that I think I maybe skipped over it was in the testing, right? Make sure you tell your developers, try to break it. A lot of times they don't think like users, and they know how it's designed and how it's supposed to work. So what do? They test it the way it's supposed to work. Well, of course, that's the way they designed it. They don't think about how will somebody else. There's a field here that says, enter a time to book something, put in ABC, right? Like, oh, there's a time, I can type in a time between 0 and 2,400 hours. What if you put in 2,500 hours, right? Like, test things outside the limits. Like, that's getting a good QA tester is important, because no matter how much you tell your developers to test it like users and test it outside the limits, they will always default to testing it the way that they built it. And then once again, automate the building, automate the deployment, right? You can schedule things, right? It reduces mistakes, human errors, right? Someone missed copying that file, right? If you're deploying like 100 files, you want to make sure that all those 100 files go together, and because they all have to work in lockstep, and you want to make sure that the database changes go with the files, right? Because if there's code that accesses the database field and you haven't put that in the database yet, you're going to break things. So if you know that there's 10 different pieces that have to go together, automate it so they all go together. And then take the time to set that up from the start. So if it's like, we'll do that later, then you got to go back and rework it, and right. And ensure that the automation is documented, because what'll happen is I got rid of all my development team recently, and it's like, okay, how does that software file, like how does that output get generated? Oh, there's a script running somewhere and I got to go dig and find it, and it's not documented anywhere, right? So it's like trying to reverse engineer the process. Just document the process.
Yeah.
All right, so this is the final section. We'll go over some recap, some best practices, some other piece of advice, and then we'll open up to questions. All right, so before you start, build the process. Go through all these things, and even if it's rough, just put something down. This is where we're going to store the code. This is how we're going to release the code, right? Like, put down something, even if it's not verbose. It's not that hard to write a short document on how a few things work. Set up 3 environments. Make sure that you have either 3 full environments or 3 branches: dev, test, prod, right? You want, as your team grows, you want people developing the next set of features, but the last version they released is being tested independently, and the last version that was successfully tested is in production, right? So these things run in parallel, allows you to parallelize your work, and allows you to make sure that you're not going to break production. Like, dev features are 2 steps away from production. Prove that they're independent. So one thing that I had a development team that did one time was they set up the 3 environments, but this test server went down and all of a sudden it broke production, because production was referencing a file from the test environment. So what you want to do is, as you build this structure, take down the test environment and take down the dev environment to make sure it doesn't break production. Because sometimes they forget that there's dependencies. Like, a common thing is, the source files that are being interpreted that are in production are accessing a database, which is actually in dev. So someone makes a change in development, it breaks production. Assign a test resource that is not a developer. yes, when you start, your developers are going to do your testing. I mean, even if it's the product manager is doing the testing or a salesperson is doing the testing, they think more like the user and they'll have that independence. They won't know how it's built. So they won't know how to test it. So they'll break it. There are QA people and test people that make a living off of just coming in and bashing your product and breaking it. And most good QA testers, as soon as dev releases something, within 5 minutes, it's broken. Guaranteed, all the time. And then ensure that every feature, bug, and fix is trackable to a version. So, that's why it's really important to do like bug and feature tracking with like a numbered record, and then have release notes, and then to use like some kind of smart versioning to make sure that you know what's in what version. So as product managers, be in clear and as detailed as possible, right? Developers don't think like users, use lots of pictures, state diagrams, and everything so that it's not just someone's got to read a bunch of words and interpret your writing. It's very, very clear if you're using diagrams. Ask to see the technical requirements, ask to see the design documents, right? If you close that loop and you see how they interpreted what you're telling them, you might be able to catch some things that they missed. Review the outputs, right? Make sure they match the requirements. If they deliver something that's good enough, figure out why they didn't do what you asked. Was it because they couldn't do it? Because they didn't understand it, right? There's a lot of times you get to the end and you get something in production, you go, well, that's not what I meant. If you do all these steps along the way, you're really clear on your requirements, the design gets done, you check the design, you don't end up at the end of the thing getting released to production and go, whoa, that's not right. This is what I meant. And then, someone's got to be the internal voice of the customer. So someone's got to go, yeah, the customer's going to accept that or not, because a lot of times things will deviate. So, make sure that that's established when they're making changes and they're making decisions that deviate. They come to you and say, okay, Mr. Customer or Mrs. Customer, what do you want here? I have to make this decision. What do you want? And don't settle. And that's sometimes you're going to have to settle because it's not just physically possible or it costs way too much. Nothing is impossible. So when they say that can't be done, say, give me the time estimate so that you can get a cost. So you can go, okay, it's going to cost me $500 to do it this way and a week, or it's going to cost me $10,000 and a month. Then you can go, okay, it doesn't make sense to do that because nothing's really impossible. It just is going to take different programming languages or different designs or different skills, right? So everything can be done. It's just going to cost more, right? So don't ever accept, no, it can't be done. And then in terms of managing developers, we've talked about a lot of these, force them to build a set of technical requirements. Don't allow them to skip the design phase. Make sure that they're thinking about how to test those units in the system. Ask them whether they're testing for failure or testing to see how it works the way it's supposed to. At and outside limits. Irrational type operations. Right? Users are not very smart. They're going to do things they're not supposed to do. Ensure they automate things. Push for automated regression testing. So a lot of these are just highlights of what we talked about, but that just kind of put them on this slide to make sure that you don't forget. All right, so that's it. Do you guys have any questions? Easy as pie.
Probably gonna watch this video again. This recording.
Yeah, that's probably what I'm gonna do too.
Yeah, so I'll make the recording available. It's being recorded to stream right now, so I'll pull down a copy of it and make it available. And I'll give you the slides too, because sometimes you just need to review the slides. But
it's definitely very helpful for sure. I think like overlooking that will be one of my biggest challenges, is just making sure that it's done properly. There's so many things to think about. Oh my gosh.
Yeah. Well, but here's the thing is, if you hire a senior developer, like a development manager or an architect, they should know to do these things, and you just need to hold them accountable. So you just need to know that they should be done. You don't need to do them. So, that's why I kind of worry with you, Megan, is I know you've hired a junior developer in a lot of cases. They're probably going to do things.
Yeah, it's not yet confirmed, but that's also one of my concerns as well.
Yeah. So, I mean, it's, the rule of thumb basically is I like to have 3 like at least intermediate people to 1 junior person, right? Like
Okay.
I don't rely completely on interns or, you know, new grads. So, you know, it's like, yeah, it'll cost you more money for somebody more senior, but you won't do it 5 times, right? You'll do it like 2 times. It's still not going to be the first time. And, you know, and the more junior of a developer you have or set of developers you have, the more that you have to do the process. You have to ask yourself, are you capable of learning everything that needs to be done and holding them accountable and making sure that they're doing the right things? Or do you have other things you need to focus on? Do you need to make sure that, you know, that's an important hire, right? So it's really about, you know, most people can understand all of this stuff. It's just about whether you can research it all and enforce it all and document it all, or do you have somebody that's senior enough that, you know, if you can get intermediate people, they'll probably know what to do because they've been in a development team before, so they'll make less mistakes, but they still, developers, like I've had some really senior developers that have had like 20 years experience that did the right things, but never documented it. So when we brought in junior people to augment the team, we had like lots of intermediate and senior people. All the junior developers failed because they didn't know what to do. And the person had to stand over their shoulder and say, no, do it like this. And so it took a lot of time from the senior development team. They're spending all their time training the junior people, as opposed to saying, here's our coding standard, follow this. Here's our merging and branching standard, follow this. Here's the process of where you store your files and how you do that. Okay. So it really becomes important with junior staff to have more process, and you can't expect the junior staff to build the process.
So would you say that like for like your repository, like the storage, would you say the developer typically would have that? Or like I have my code, but would you say that there's a good way for me to store that in my own system?
So how do you have the code? Do they just like put it in a zip
file? It was sent to me in a package in a file.
Yeah,
but I don't know.
That's a copy of the code at a particular instance. It really should be in a version control repository, and they might have it in that. Like common things, like you can ask them, like, what version controller are you using? Can I get access to it? Because really what you should do is you should have the master account. So instead of getting a copy of your code, what you should do is you should have the master login for your version control system. And it's going to be things like GitLab or GitHub, or it's going to be Perforce or Subversion. There's a whole bunch of different types of like different brands. But most of the modern web development and stuff is usually done in like GitHub, which is online. So you should own the account. And then if developers leave, you just delete the developer and add the next developer, right? So it's always living. And then, because when a new developer comes in, if they just have a copy of the code, they won't know what happened before that, right?
I think I have that. Yeah, I do have that.
Okay. So as the owner of the business, you want to like be in control of that, right? So
yeah. Okay. Oh, so much. But awesome. Like such like, yeah, I definitely would have benefited from this like during Junction for sure.